We look at a category of questions now called rates of change. So far in calculus, when we've had an equation like y is equal to x squared, we get dy dx. That is the rate of change of y with respect to x. This is, I suppose, just maybe the next stage of this. Some definitions: s is displacement or the distance, v is velocity, not s for speed, so don't get mixed up with the s and the v, and a is for acceleration. You know velocity is meter per second, kilometers per hour. That's an average velocity. If you want to get instantaneous rate of change of velocity, it's going to be ds dt. As you can see, you've got the distance or displacement on the top, like meters, and on the bottom you've got the time. So if you have a displacement like s is equal to 3t squared, well, ds dt, or velocity, is ds dt, is going to be equal to 6t. And that'll be, the units for that would be meters per second. So that's my first derivative, will give me my velocity of the displacement. If we want to get the acceleration, well, acceleration is the rate of change of velocity with respect to time. So acceleration, I'll do this in yellow to just alternate colors. That'll be the derivative d dt of v. dv dt would be acceleration. That's acceleration equals that, which is also equal to the rate of change, d dt, of ds dt. And that's equal to d2s dt squared. This is all acceleration. Okay, so we have a ball that's kicked vertically up and its height is given by this function here. And then 4 questions. What's its height at t is equal to 1? Well, to get that, I just sub in a 1 into the function. So I'm going to go, so h1 is going to give me 20 minus 3 times 1 to be squared, which is going to give me 17 meters high. So 17 meters high after 1 second. In order to get its velocity, I need to get dh dt, so let's do that. So dh dt, or velocity, is equal to minus 6t. At t is equal to 2, I'm going to get minus 12 meters per second. So it's coming downwards at 12 meters per second, its velocity. In order to get the acceleration, I'm going to get the derivative of minus 6t, because that's its first derivative. I'm going to get dv dt, which is acceleration. That's going to give me minus 6. And that's minus 6 meters per second squared. So that's what its acceleration is all of the time. The last part is what's its maximum height. What you need to know for this is that when the ball goes up here at its high speed, when it gets to the very, very top, its velocity will be 0 before it comes back down again. So you need to get its velocity equal to 0, and then you can work out what its max height is. So to get its max height, I'm going to get the velocity, which is equal to minus 6t. I let that equal to 0, so I'm going to get minus 6t is equal to 0. So that's very easy. I know that t is equal to 0. So its maximum height happens at t is equal to 0. In other words, from the moment this ball is propelled upwards, it's actually moving downwards. So its height is going to be so h is equal to, there's our function here, 20 minus 3t squared. So 20 minus 3 by 0 squared, which is equal to 20 meters. So that's its max height.